Okay, guys, so today's lesson is something I'm not really going to be testing on it, but it's something you should know. We're going to be talking about logic and logic and truth tables and truth values. If you're thinking about doing programming and like coding, it'll be really helpful, and the rest of the unit will be helpful. Anyway, let's talk about something: a compound proposition. Compound proposition is a statement which are formed by using connections or connectives such as and or. Are statements, which are formed using connectives such as and or. And we're going to, if we use the word conjunction, that means and the word disjunction, we talk about the word or. Once again, I'm not testing you on this, but it's helpful to know that you've seen this stuff. So, for example, if I let P be Sally had a salad for lunch, and we let Q be Sally had a sandwich, then we know simply if I use this symbol, let's use this symbol to represent P and Q. Or Sally had a sandwich for lunch and Sally had a sandwich for lunch also. If I use this symbol, the V, that symbol is for P or Q. Now, there's another symbol. This is P. This is the exclusive Q, and this means an or statement that can't be true at the same time. For example, I am 15 or I'm 16. Or when you say you can have this or that, but you can't have both. Versus I want a t-shirt and it could be blue or long sleeve. So, let me throw this pen away. I apologize. So, the next thing we want to talk about is something called a truth table. Let's talk about truth tables. Because I don't know if she actually had a salad for lunch, and you don't know if she had a sandwich for lunch either. So what we can do is we can go through all the possible combinations of these two statements and see how they work out when we connect them with an and or an or. So I'm going to make a table, P and Q. Now, the quick way is true, true, false, false, true, false, true, false. What have I done here? Well, I've created all the combinations. Let's think about this. Either both are true, the first is true and the second is false, the first is false and the second is true, and they're both false. So what I've done is I've created all the combination. Now, let's bring them together. What was the first connective? And. P and Q. If they're both true, then the entire statement is true. If one part is false, the whole thing is false. And if both of them are false, then the whole thing is still false. Now let's take a look at or. Well, Sally had a sandwich. Let's say that P and Q are both true. Sally had a sandwich, or she had a sandwich. Oh, that's true. let's say that she didn't have a sandwich for lunch. Is it true that I think she had a salad or she had a sandwich? You can say, yeah, one part of that is true, so that's true. So that would make the third thing true, false or true. What about false or false? False or false? It's all false. Now, the last thing is the exclusive or. Now, the exclusive or is the cases when your mom says you can have ice cream or you can have cake, but you can't have both. So true. I had cake and I had cake and I had ice cream. No, that's false. I had one, but I didn't have the other. Good. I didn't have the first thing, but I had the second thing. That's okay. I had neither. Good. No, I'm sorry. Sorry. False or false? Exclusive? False. Okay, once again, I'm not testing you on this, but it's good to know. Now, what I do expect you to know is when we link statements together with if-then. So, if two propositions are linked with if-then, then we have, what do we have? A conditional statement. So if P, then Q is written as P arrow Q. It's also written as or, and the idea is that P implies Q. That means if P were to happen, it would lead to Q. Also, and you might have learned this from your science class, P is known as the hypothesis. And Q is known as the, what do you think? The conclusion. Now, here's the conclusion. This is kind of interesting. So the exercise are going to say, they're going to give you a bunch of if-then statements. And then the part right after the if is the hypothesis, and the part right after the then is the conclusion. Now, the idea, let's go through the truth table of this. So P implies Q. Okay, true, false, true, false, true, false. Once again, if my hypothesis is true and it leads to the conclusion, is the whole thing true or is it false? Well, let's get one thing out of the way. First of all, very advanced thing. Once again, I'm not testing you. What if I just start off with something that's totally not true? Well, according to logic, if I start off with a false hypothesis, no matter what I lead to, it ends up being true. Outside of the scope of this class, you can explore that, investigate that, that's great. But let's talk about truths leading to either true or false. The way I like to explain this is two ways. First of all, I'm going to ask you to come up with your own truth. My truth is, if I eat ice cream too fast, then I get a headache. That's my truth. So, I want you to come up with your own truth. Once again, my truth is, if I eat ice cream too fast, then I get a headache. Okay? Okay, so I want you to think about this, what your truth is. So, is it true for me that when I eat ice cream too fast, I get a headache. For me, that's true. Now, let's take the scenario. If I eat ice cream too fast, I don't get a headache. Is that true for me? No. No, that's not true. Therefore, it's false. And these are the two things we're really interested in. We're really interested in true. If true leads to true, then it's true. Versus true leading to false being false. My second example of true implying false is discrimination. So you might see someone from a certain group doing something. And it's true. You're witnessing that person doing something. But if you were to conclude that, oh, I guess everyone from that group does the same thing, that would be false. That's so once again, discrimination, racism. Oh, I see, sexism, homophobia. Oh, I see one person doing it. I guess all people like that are just like that. So that's the idea of false. True implying a false is false. Okay? So what's the next thing you have to know how to do? The next thing you'll be asked to do is, how do you turn a regular a next statement into a conditional statement? So writing a statement as a conditional. So for example, hold on one second. So for example, I'm sorry guys, I apologize. So, yes. So here's what you're going to do, because the book has a weird way of doing it, but I thought of something interesting. So let's here's a sentence: vertical angles, vertical angles share a vertex. How do we write that as a conditional? Well, I'm going to say, question the person who asked it. Say, wait, do vertical angles... So first, ask as a question. Ask a question. Do vertical angles share a vertex? Do vertical angles share a vertex? And you say, yes, Mr. Adler, if two angles are vertical angles, then they share a vertex. And there you've just written a conditional statement. Answer, yes. If two angles or vertical angles, then they share a vertex. And you can do this with anything. Let's use a math example. All even numbers are divisible by 2. All even numbers are divisible by 2. So you say, wait a minute, is that true? Are all even numbers divisible by 2? And you would say, yes, if a number is even, then it is divisible by 2. Is this true? Is this true? And you would say, yes, if a number is even, then it is divisible by 2. Does it have to be a true statement? Does it necessarily have to be true? No. Well, we can still write it in. We can still write it as a conditional, but we can find a counter example. So, for example, all Mandarin speakers live in China. All Mandarin speakers live in China. So first of all, let's assume it's yes to get the conditional, but I think someone knows it's not true. So let's say that first of all, let's assume it's true to get the conditional down. All Mandarin speakers live in China. So you would say, so let's say I said, oh yeah, that's totally true. Yeah, if a person speaks Mandarin, then they live in China. Right? Is that true, though? That's the conditional. Is that true? And you would say, no, I have a counterexample. What's the counterexample? You say, no, this is false. Because there's plenty of people who live in other countries. They live in San Francisco. They might live in Singapore. They might live in France, but they speak Mandarin, so go false. But once again, this is the conditional. It's false because we have a counterexample. That's the idea. Does the hypothesis lead to the conclusion? No. Just because you speak Mandarin does not mean you live in China. So once again, true implies false. True implies, so 2 lessons in 1, actually. So we turned our statement into conditional statements. In the first one, you said, yes, true leads to true. Therefore, it's true. In the second statement, you said, wait a minute, Mr. Adler, that's great that you wrote a conditional statement, but this true leads to a false. Therefore, this whole thing is false. If you can find a counterexample, it's false. I think I just came up with a quick way to finish this lesson really early. Hold on one second. I apologize. No, that's it. Oh, the last thing I want to do is, okay, I apologize. The last thing we have to do is important, is related conditional statements. There's 3 things we do need for this class, and you will need for like program, like if you're going that route and you're thinking about logic and logical structures, this is going to be important. The first thing is, once again, let's hold on to this idea of our original P and Q. Let's hold on to my original truth. If I eat ice cream too fast, then I get a headache. Well, we can have 3 things. The first thing is called the converse. And the converse of my truth is Q implies P. The next thing we're interested in as logicians is the inverse. The inverse of my original truth is not P implies not Q. And the third thing we're interested in as logicians is the contrapositive. And that's not Q and not P. So a converse is switch. The way I was taught it is converse, seeker, switch. The inverse is negating the hypothesis and the conclusion, and the contrapositive is flip it and negate. Okay? Once again, this is not an IB exam, but this is good to know if you want to do programming and coding and all that stuff. And the law, actually. These are arguments for if you want to be a lawyer. Let's go over the truth tables for this stuff. P implies Q. The first thing we have was P implies Q. Remember, right? Hold on a second, because there's negatives in there. Sorry, once again. So we're going to do not P and not Q. We have P implies Q. Let's start. We true, true, false, false, true, false, true, false. What's not P? Well, if P is true, true, false, false, that means not P is false, false, true, true. Oh, my computer shut down. 1, 2, 3, 4, 5. How are we doing? Oh, we're at 20 minutes. Okay, we're almost done. Not Q. If Q is true, false, not Q is false, true, true. We said that P implies true. P implies Q was true implies true, true. True implies false, false. And then false implies true, and false implies false is both true. Okay, that's the next. Q implies P. Q implies P. So you're going to need Q implies P, not P implies Q, not Q implies not P. Okay, let's see about this. Ready? True implies true, true. False implies true, true. True implies false, false. False implies false, true. These aren't the same. And that should make sense. If I eat ice cream, then I got a headache. If I got a headache, does that mean I ate ice cream? We don't know. Here's another good example. If it is August, then it is summer. If it is summer, then it's August. We don't know about that. Not always true. So once again, this is the conditional. This is the converse. Now let's take a look at the inverse. Not P implies not Q. Ready? False implies false, true. False implies true, true. True implies false, false. True implies true, true. Once again, if my conditional has values, it's not the same as the inverse. If I eat ice cream too fast, then I get a headache. If I don't eat ice cream too fast, then I don't get a headache. I don't know about that. I could still get a headache, right? If it is not August, then it is not summer. I don't know about that. What about the contrapositive? Not Q implies not P. Okay. False implies false. True. True implies false. False. False implies true. True. True implies true. True. Now here's something really cool. The contrapositive is the same thing as my original conditional. If I eat ice cream really fast, if I eat ice cream fast, then I get a headache. If I don't get a headache, then I didn't eat ice cream really fast. Yeah, that's true. If it is August, then it is summer. If it is not summer, then it is not August. That's true. And it turns out there's a name for when these things are true. It turns out that because the truth values are the same, which I'm never asking you on a test, I'm not asking you to do truth tables unless you want exercises with truth tables. I'm not asking you. The idea is these are logically equivalent. If the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false. You know, it turns out that the converse and the inverse are actually equivalent also, but we'll get to that. But once again, the idea is the conditional and the contrapositive, but the conditional and the converse don't have anything to do with each other. For example, a square has 4 sides. If a figure is a square, then it has 4 sides. If a figure has 4 sides, then it's a square. So that's what we're going to be talking about in the next class. Yeah, that's it.